Well, many questions about homework. Actually, homework 1 and homework 2 seemed like they were pretty okay. Nobody asked too many questions about those. There was one common question on, I think, homework 2, and it had to do with the y-axis coming out random. Like it was just random numbers. And the deal with that is the y-axis being captured as a string, which is what it comes in as by default, and then you need it to be a integer or a float or something so that it actually orders it versus just putting it in whatever order it came in. So if you had a y-axis that was looked random instead of ordered, then it was probably bringing it in as a string variable and not converting it over to a float or integer. So number 3, however, had lots of questions, and there's lots of little problems with number 3. One of them is the data itself. So it sent you over to the Bureau of Labor. It's full of, well, it's all kinds of problems. So one problem is somewhere around 2012. Oh, I probably still have it. Let's see. It changes headings. The names of things change. Don't need that anymore. And so it's difficult to use something like pandas that relies on these headings or whatever. So I did not go that route. Some people did. Some people went that route and made it work, but they did have to go in and edit the headings and the names. Like I noticed biomedical engineers in one set of data from 2005 to, I don't know, around 2012 was biomedical engineers with a lowercase e, and then they flipped it to an uppercase e. And so those are different values. You could have coded it or whatever to possibly detect both of them. But anyway, that's not the route I took. And the route that most people took was something like this one, I think. Maybe not exactly like this, but this is what I ended up doing. So I first grabbed all the Excel sheets, put them into one Excel notebook, each year having its own sheet. This one, I took and grabbed just the stuff we wanted. So I took the name and then the 10, 50, 90, so the 10th percentile, the 50th percentile, and the 90th percentile for each of those years. And I might have actually copied the wrong data here because these look out of scale with the others. I didn't go back and check, but we could fix that if it is a problem. So anyway, there's 2005's 10, 50, 90, 2006, 10, 50, 90, and I did that for all the 6 that we're interested in. So I did it this way because I was going to use a similar approach that we used in problem 2, where we basically broke this data into a list and then made it a list of lists. So I could talk about any individual piece. So here is the code that I wrote to make this happen. So I saved this as a BLS, so Bureau of Labor Statistics filtered, because I filtered out only the stuff that we wanted. So that's not it. Let's open, what did I call it? I guess it'd be that one. Yes, I wrote some of this 10 o'clock last night. Is this the right one? Yes. Yeah, this is going to do the right thing. All right, so I used custom functions. I used the custom functions to do the break in the CSV. So I did save it as a CSV file. And I used PyPlot for the plotting, like I assume everybody else did. So we did this before. This was exactly what you did in problem 2, where you had a data file and you opened it up. And I'm not using pandas, so I had to have a CSV, or at least I chose to use a CSV. I read that into this variable f, split it up based on the /n, which is like hitting the enter key, so it splits it up wherever a row ends. I made an empty thing. I just called it sales because that's what we called it in homework 2 and in the example for the NCAA football thing. I made a list with the years in it. I guess I could have grabbed that out of the CSV file, but I didn't. I just created a list with the years. So this is basically going to be my x-axis, that one. And then here, well, this is actually stuff that you already did before. This is splitting it into the different lists, so that I have a list for the top row, a list for the second row, so a list for biomed, a list for chemical, a list for civil, and so forth. And all of those lists are in a bigger list that contains them. I popped off the top 2 rows because in my list I did have row 1 being the years, and row 2 had some data in it. It was not useful. I mean, I only did the first 3, but I popped those off because I didn't want them. Then here is, and if you don't follow this right away, that's okay. I'll post this code so that you can go and look at it. And if you ever want to try and figure out what it's doing, again, the whole point of what we're doing isn't to learn Python. We're just going to use Python to do data collection and analysis type things. So if you end up learning some of it along the way, that's good. But for me I would not expect you to recreate this thing. So these I and J, these are just index values for the subplot. So I'm going to make the little output where it has one figure with the 6 subplots in it. So I is the row that addresses a subplot, and J is the column that it's in. So 0, 0 is the top left subplot. This creates the plot itself, the big figure that's going to contain all the subplots, and it's a 3 by 2, so it's 3 rows of plots, and they're 2 columns, so that's the 6 plots. Mine on my now when I do it on this resolution, it's probably going to be too big, but on the native resolution for this monitor, I had to make it kind of large to see it at all. It came out like a tiny little postage stamp. So this fig size is a thing that you can modify to make the big container plot bigger or smaller. So we'll probably have to make that smaller on this resolution. And then here are, let's start at the bottom and work our way back up. So this one just shows the plot once it's all populated. This part, well, actually, and the I, those, remember I and J, they're the indices for where to put this particular piece of plot. And so this is how I'm iterating through, go to the top left, now the middle left, the bottom left, top right, middle left. That's what this is doing right here. It's just changing the indices. Here those indices are again. So this is actually populating the plots with whatever they're going to have on them. This line is one that we didn't use. I thought it'd be nice to have all of the plots have the same range on the y-axis, since you might want to compare them, and by default it's just going to kind of scale them dynamically so that whatever data you put into them fits on the plot. But I looked and saw that nobody had lower than 30,000, nobody had higher than 180,000 in this data. This was dollars per annual salary. And so I just made those the limits, so all of the plots will have those same limits on them. These are set in the axis label, so I hard-coded in the axis label for the X and Y axis. The title I didn't hard-code in. What I'm doing there is right here, it goes and grabs column 0 out of rows is one list. So row 0 is biomed, row 1 is chemical, row 2 is civil, and so forth. And so it grabs the first element in that, or the first entry in that row, which is the name, right? So this is row 1, or row 0 actually. Row 0, element 0 would be the name. And so I just stuffed that into this variable called major, and then I put it on this plot. These are the 3 trend lines, so the 3 lines, the 10 percentile, the 50 percentile, the 90 percentile. Those get populated through this part right here. So this is all it actually takes, and I could have made it a little bit shorter, but this is about all it takes to get all the data from here into all of the plots, all 3 lines, and using this format for the data. Now, if you had a little bit different format, it would look different, but this is what it takes to actually populate all of the subplots. So you'll see in here some of the grayed out things. This is a handy thing to print values of variables along the way while you're troubleshooting, because you'll think that, so this length, LEN, that's giving me the length of the row. So basically it's the row and it counts how many elements are in it. So 43 or whatever, if you grab them all. Yeah, there's 43 down there. So that would print it out. And so I'm doing that on this boy. I commented it out, but I was doing it to make sure I was actually grabbing a row that had 43 elements in it like I expected. If it was grabbing some other number of elements, then I got to go figure out what's going on. So it is handy to put in little print statements every now and then when you have a variable get an assignment, then print out what it assigned in there to make sure it's actually assigning the thing you intended it for it to. So that's what those are doing. These establish the empty list for the 10th percentile, 50th percentile, and 9th percentile salary numbers. And I reset them every time. So the coding that you've done with Arduino, they have like a for next statement. This is the same type of thing, except it is not set to a certain length. So it's for every row in sales. So sales was up here. That is all of this data. So no matter how much data I put in here, I don't have to hard code in for I equals 0 to 5 or 1 to 6 to get the 6 rows here. It just goes in how many rows are in this thing sales, which contains all of this, and iterate over those rows. So that's what that does. And the variable names are not like, you don't have to use rows. I just used rows because it made it easier for me to remember that that's what I'm talking about. And I used entry over here. So entry is like, this is the 0 entry, this is the 1 entry, this is the 2nd entry. So those names are not important. They're just familiar to help me track what's going on in this loop down here. So for every row that I have in my database, basically, it's going to do all of this stuff, all of the indented stuff. So first, it empties out the salary data because the first time they're empty, but the second time they've got the biomed data in them, and I don't want the biomed data, I want the chemical data now. So I empty them back out. So that's what this does. It makes them empty again. And then I go fill them with the chemical data. Then the next time through, it empties out the chemical data and puts in the civil data and so forth. And like I said, this is where it grabs the name, biomed, chemical, civil, whatever. And then here is for entry in range. So here, this range, what this is doing is this is a start point. So entry 1, which row 1, entry 1 is actually this one, right? Because this is entry 0, biomed is entry 0. Entry 1 is the salary for the 10th percentile in 2005, the way I have it arranged. I could probably make those bigger. So that's entry 1. That's where it's at right now. So that's this entry. Length of rows. So again, it doesn't have to have a specific 43 is the number, but if I wanted to go to get the 2019 data, use the same code, I add it to my CSV file, and it knows, oh, now there's another set of numbers to go grab. And so it's not hard-coded in that it's only going to iterate over the 43. It dynamically chooses however long that row is, that's how far it's going to go. So this is the start point. This is not actually this is the stop point, I would say it. So once it gets to this number, then it stops. It doesn't actually do that. It's a closed end over there, or well, I guess it's open on that end. Anyway, this is basically the number of rows plus 1 is a way to think about it. And this is the step size of 3. So I did 3 because I did the 2005 10th percentile is here. You skip over 3, and there's the 2006 10th percentile. There's the 2007 10th percentile, and so forth. So it's skipping over 3. So it appends to the 10th percentile data all of those 10th percentile salaries numbers. And then it goes in, same thing, except it starts on entry 2, which is the 50 percentile, and then it skips over 3 and grabs all the 50s and puts them into salary 50. And then here it starts on entry 3, which is the 90th percentile, and it skips over every 3, puts those into salary 90, and then I plot them. So salary 10, 50, 90, and then it adds the labels and the scale and everything for each one of those plots. So if I run it, hopefully it will create, well, again, it might make, yeah, I made it giant, so kind of big. It fits on there, though. It's on there. But see, I think I might have grabbed some data that's not right because that looks weird on the front end of all of those. But then it plots them. they all have the same scale, and it doesn't actually show the 180 because of the, I can't make it large enough. I'd have to make it smaller to actually scale it up big enough to where it's not going to be weird. And you can change, or over there, you can change the size of it over here. Maybe 15 would make it fit on this particular screen better. Well, it's still overlapping. There are a lot of other tweaks that you can make to the subplots themselves, like the spacing between them. Since these two columns and actually all the rows share the same axes, I could have just the axis show up over on the left-hand side and not these in the middle. I could have the x-axis only show on the bottom and not on every one of the plots. I didn't bother to do all of that level of stuff, but because right now it's kind of overriding all the names in there, so I could turn off these 2006 through 18s on the top ones and leave them just on the bottom, since they all share that axis. There's a lot of that kind of stuff that you can do to make it look better. I just was trying to get it to plot the stuff, and so that is it really is just this once you have your data, and that's the powerful part of coding. Now, not just Python, but coding in general, because this isn't crazy. It's 6 sets of data. You can manually go in and create 6 Excel files, throw them into something, and have it plot. And so it's not crazy. But what if you wanted to plot all, I don't know how many hundreds of these careers they have on those websites? This method will go, and it doesn't care if you have to plot 200 plots or if you have to do 6 plots. But if you were doing it by hand, grabbing each one of those data, making its own Excel file, then it starts to get cumbersome. If we had to do all of them, even creating this file would have been I would have automated that process. I did this one by hand, where I just cut and paste them into the right spots, because there's only 6 of them, so it wasn't that big a deal. But even that would have needed to been automated. So again, it's not something that I would expect anybody to have this as their solution for homework 3, but just know that there are ways to start thinking about things when you have larger and larger data sets, because we're going to do some near the end of the quarter where you're going to collect data for 24 hours. So you're going to have a 24-hour data collection set that's going to have hundreds, thousands, hundreds of thousands, maybe, data points that you got to do something with. So thinking about how you're going to record that data to make it useful would speed up this process. If you put everything in a row, then maybe that's good, or everything in a column that matches, then that's good. So things like that will pay off later on in the quarter on automating some of the manual cutting and pasting and arranging the data just the way you want it. And I will post this, because I don't know, this particular one won't be useful, but maybe this little set of how you can populate multiple things in basically just one nested loop here. Well, these are each their own loops, and they're inside this loop. And remember, Python controls these loops through indentation. So this loop ends when I'm no longer indented. So all of this is in that loop, and then once I've finished that, iterating over all the rows, then this is not indented. That's when it finally shows the plot. So if you notice, when I run it, it sits for a while. That's it thinking, and then it shows up the plot. Actually, that was faster than it had been. Maybe because I've already done it. I don't know. But all right. I'll post this on Moodle so you can look through it. Parts of it might be useful later on. However you did homework 3, I don't care particularly if they're all in one figure, and like I showed them here with the subplots, it's not terribly complicated to do. I did notice that it's really hard to find a good, like if you're Googling subplots in Python, it's really hard to find a good way demo of how to get that done. I couldn't find that easy to follow one, mainly because there's Python. A lot of people intentionally have not transitioned to the 3 version of Python and they're still doing the 2 version of Python, and some things are different. There's all these libraries that some people, maybe they're not using PyPlot, they're using something else. I don't know. And so there's a little difficulty in finding ways to make the subplots, but they're actually really easy. You know, you assign your how big or what shape is the array of plots going to be, and then when you plot into them, you just address the individual plots by their index, and that's it. So, but there are a lot of other ways too that makes it confusing when you try to go search on how to do that. So anyway, I'll post that out there, and you can look through it. And if you want to, you don't need to. As long as you turned in something that made some plots and they look like those salary lines, however you got there is okay with me. Let's see. We can close this and close that one. I think what I want to do now. Oh, I just realized that this might be really dark. Let's see what it looks like. I may have to. I don't know. On my screen, it's not terribly dark. On there, it kind of is. So I don't know. We'll see. All right. And I may have to like fake solder and not actually do anything. We'll see. First of all, the room over, like right next to us, there are 3. I think they're pretty much this exact same setup. They may be locked to where you can't change the temperature on them, which is probably a good thing, because, and I don't know if it's going to show up very well. This tip is still, that's visible of what's going on. This tip is still okay. This endpoint, if it is not silver, mine's not perfectly shiny, but at least it's not black. If they are charred, then what has happened is somebody has thought, oh, it'll be easier to solder if I just put more heat into it, which, yes, that makes the solder melt faster, but it doesn't necessarily make the solder any better. So what happened is that tip basically charred off its coating, and if it's not silver, or at least kind of silver looking, then it's not going to solder anything. It doesn't matter how hot you turn it up, it's just not going to work. Either the solder is going to stick to the tip and never come off on what you want it to come off on, or it's really just not going to transmit enough heat to do what you want it to do. So make sure that the tip on what you're about to use is clean and silver, or at least sort of silver, argent maybe. The shinier they are, the better, but they're going to get worn out. There are some replacement tips. Oh, to replace them, you just unscrew this whole thing, and then they come out. You put them back in. So there are 3 or 4 replacement ones over there. If you find one that's just burnt beyond hope, there are ways to recondition them. I've never actually bothered with that because they're kind of cheap. They're not like pennies cheap, but they're cheap enough that you can put anyway in. All right, so what we're trying to do is, let's get my parts. Oh, yeah, and like you were saying, there's this shield, and in a bag, there's another one that looks similar to it, but they're different things. So I'm going to spill parts everywhere. So let's talk about what these different things are. And you've got these little headers in one spot, and then you've got a bag that has almost the same headers. They're a little bit different. Like there's 2 short ones here and only 1 short one here. This one is just a proto board, so it just has, basically, it does have a spot where you can put in some kind of IC, an integrated circuit chip over here. This looks like maybe it could fit something like a wireless module, a Zigbee or something, I don't know. Here's a pad that you could put another little IC on, a surface mount IC. But we're not going to use any of those. Well, I won't say that, because it's possible that at the end of the quarter, when you do your group project, that the sensor you use might be an IC and it would fit right on here. You could solder it into there. So it's possible that you do use that. We'll mainly use this area here, which is just holes. They're not connected. It's not like a breadboard where they're all connected together. They're just plated through holes. So they've got these little rings around them that are plated, and red surrounding everywhere else. So the red, a lot of times it's green, but these are red. That's called a solder mask, and what it does is it makes it to where ideally solder doesn't stick to that, so that you don't get too bad a bridging between things that are close together. But you know, these are super cheap ones, so who knows the quality of their solder mask or not. But the idea of it is that you don't actually solder doesn't stick to it, so it masks the solder. So what will happen? I don't have an Arduino with me, but what will happen is we need to put these things in the holes. Well, got to line up the right size holes. There's one set. They're actually a little tricky to line up. Maybe impossible to line up. It's close. There it goes. All right, so you got to get them all lined up. You want it to where your Arduino is sitting down here, and this is going to plug in on top of it. And then if you use this one, this will plug in on top of it. And so these headers have pins that will plug into the Arduino, and then they have receivers that other things can plug into them. So you can just keep stacking these, and you can stack them. Well, you can physically stack them as tall as you want to. At some point, the electrical connections, you know, they do pass through, so you don't want the thing on top using pin 2 and the thing in the middle using pin 2 for something else. So that would get confusing. So you do run out of reasonable amount of these that you can stack together. But this is the one that we want to, actually, you could work on either one. This one you got to be careful with because there's 2 rows that you could put the little headers in, and you got to put them in the one that lines up with the Arduino, right? So if you're using that one, this is not the one that we're going to need right away, so I wouldn't worry with it, but you do have it. This is one that we need. We need to be able to put an SD card in there. You should have an SD card somewhere in your kit too, a little one. I actually don't see mine right now, but I assume it was in here somewhere. Mine is in the bag, and it's not in a package or anything. It's just an SD card in this little bag. So those things are super fragile. So you do want to make sure that you don't throw this bag in something that's going to get beat around, because it's really easy to crack those little SD cards like that. Particularly when it's not in a case. So you might even go ahead and put it in the shield here. I really need some more light. I don't know how I'm going to get more light. Oh, yeah. Yeah. Then I can't have my coffee. That's not going to work. It's not a good solution.
Okay. Where is the start?
Oh, yes, my phone does not have an easy to turn on light. Yeah, and it doesn't. I don't have an app on it that actually is a flashlight. They do have one, but I don't have it on there. I thought I actually had a flashlight in here. Oh, look at that. Oh, but I have a flashlight. I know. I'm slightly prepared. Now, oh, wait. Oh, you know, there we go. All right. So that'll give us some tiny. So let me show you some things. So these, like I said, these. I don't want to wash it out. Sort of like that. All right. So these are really cheap SD card shields, and you need to go in and check. Oh, there we go. Look at that. Well, I can move this. I also need something to make it not reflect off of that. Look at that. Better. As good as this is probably going to be anyway. All right. So on this shield, I have seen we bought like twice as many as we need because they're so cheap. And sometimes some of these little resistors and capacitors around the edge are not there. So sometimes it's okay. Some of them are intentionally not supposed to be there. Other times I've seen them half there, so they're standing up and not connected to the other side. And sometimes I've seen them, they're not there at all. So I can't remember which one it is. I think this one is the one I've most often seen not there at all. And if that's true, it's okay to just solder across there. These two over here, I don't remember what they actually do, but there's two on the other side that are just the solder pads. And I think I normally leave those along. I think there may be ways to like set some options on the card itself. But I think that one is the one that you want to make sure is actually there because I have seen it missing. Well, there are two over here on this other side that I think are okay to not be there. These two, and that's what, if there are more than two, and I don't think it's going to show up. I wonder if I can have, I guess zoom is like this. And then refocus. Here, let me make it. Yeah, so those two that are, well, it's inverted. So the two over there, those I think are okay. But if there are more than those two missing, particularly this one right there. Oh, wow, it's off the screen. Gotta figure out. Particularly that one. That one is the most often missing one that I've seen. It's just you solder, basically if it's there, we can give you another shield, or what I did is I just soldered across it, and it was fine. Just without it there, there's no connection for that pin, and it doesn't turn. Does it not turn on? I don't remember if it doesn't turn on or if it doesn't write to the card. It doesn't work. So these two I think are okay. I have to zoom out a little bit to see them all. Wow, this is all backwards. So these two, kind of right there, are okay, but any others, then you probably don't want to go through the trouble of soldering up all these headers and then find out that, oh, that I got to fix. And so all that to say that check the boards to make sure they're populated with all the little surface mount resistors and capacitors. If they look good and those two they're not there, that's okay. Then go ahead and solder it up. And if it still doesn't work, then there is a couple of things. There's a switch right here that switches between the two. You can use the larger SD and the micro SD. So the switch will actually switch between. It's a mechanical switch, so you can switch between the two different SD card slots. So just check that. Maybe you got it switched to the wrong side. I don't remember if they're labeled. They are. I just can't see it. Oh yeah, there's some super tiny writing down in there. And I think they're in the right order. So down is that one, or well, whatever direction it looks like. That one, when you flip it to this side, they're actually match up. So even if you can't read it, they make sense. Yeah, so at some time, whether or not you do those first is not particularly important. What you need to do, I didn't bring any helping hands. All right, so this might be a little bit tricky. So notice that, let's see if I can get an overhead. There are lots of different ways that this thing can go in there. You want it as perpendicular as possible because you're going to have, 30 some odd pins of these pins that all need to be parallel, perpendicular to the board so that they can plug into the Arduino. Now they're actually kind of long, so you have some, give in actually forcing them into the Arduino. But if you put them in where they're splayed out or splayed in on both sides, then it's going to be hard to actually plug it into the Arduino, and you're going to have to go in, soften up all your solder, and try to get them straight again. So the better job you do of keeping them perpendicular when you perpendicular to the surface here, the easier this thing's going to plug in. So that's kind of tricky to do, but it is not impossible. All right, now we'll do so. Over in the other little lab over there, they've got some helping hands where you can clamp things together. I don't have one here, so we're just going to set it down. Actually, how about we put some on both sides so that it might set evenly. What do I have here? All right, so I don't have one that matches exactly that. That one doesn't match there. These don't match at all. That one matches there. All right. These two, that one matches there, and then this one actually is not going to fill in all the holes, but you can kind of see, well, I'm sure you can't see on the screen up there, but if you look in, let's get a bigger view out here. If you look in this area, there's a really faint outline around the pins that you need to actually plug into. Basically, you don't plug into the top two, but you can actually see a little white outline around these pins on where your header needs to go. Oh, make sure you put the header in the right way too. You know, the header doesn't need to go this way. You want this to be the top so that you can get the SD card in there, and then your it will fit on the Arduino this way. So you want the pin sticking out on the basically unpopulated side here. I'll see if I can get another one of these to go in. No, I don't know. Kind of tricky in the dark, particularly. Not too bad. All right. So that way it'll sit flat since I don't have, that one actually is much stiffer too. There it goes. All right, so the idea here, my soldering iron is not on right now, but so the idea is that you will take, where'd my solder go? Oh no. I really don't know where it went. I have flux of that kind of paste. It was a little spool of solder. It could be in my bag, I suppose. Doesn't matter. I just wanted to show you where to use the solder. All right, we'll use some fake solder right now. Imaginary solder. All right, so this will be our imaginary solder. All right, so the idea, now I don't know the exact tips that are on the soldering iron in the room over there, but I think they're like this one where it's a little bit flat. So it's like a really blunt, a really blunt flathead screwdriver. And so if that's, I think that's what's over there. If not, then just, it'll work similar. But you take the flat edge, and the idea is that you want to have as much surface area on the touching the wire here, or the pin, and this little round circle. So you kind of want to pick a side, probably the outside would make most sense, and hold it sort of like this so that you're touching on the plated circle, this hole, and you're leaning against the wire a little bit. And then so you'll let it heat up for a little, I don't know, you'll have to see what good works for you, 5 seconds maybe, I don't know. And then you introduce the solder from the other side, and it should melt the solder, and then you pull away, and there should be a little, sort of looks like a shiny cone at that base there. If it's a blob, if it's round like a sphere, then it's got a cold solder joint, and it is going to give you problems the whole time. It's going to be, sometimes it'll make connections, sometimes it won't. What you want is you want for that solder to flow into the circle and then pile up in a cone shape on the pin. And I don't think there's any way we can actually see that here, and I don't have solder anyway. Flux will help. So in the room there's paste flux. I actually have a pin flux, which I don't think are in the room. I like the pins a little more because you don't have to like try and figure out how you're going to get the flux from the little container onto the thing you want. That's always a pain. These, it's like a pen, it's like a marker, and you can paint it on there more or less. I don't know if there's any over there though. The flux, and it's not 100% necessary. You can make solder happen without the flux. The flux just helps it flow better and not blob up as much. And it also helps your solder mask work a little better too, so that it doesn't flow where it's not wanted. On your soldering iron, if the temperature is adjustable, then don't adjust it up super high, because when you run it up really high to 800 or whatever these things max out at, it's going to burn up the tip on here, and you're not going to get any kind of reasonable solder. I don't know. I think you have, and I don't even have any of the solder, but I think you have lead-free solder over there. Now, you may have your own solder, I don't know, but just do a search, whatever kind of solder you're using, and see what the melting temperature where the stuff is. All right, so, well, the tin lead, which is probably not the one you have, is 360. You probably are using the lead-free, which is higher, 420 something, 430. You want to go right around that temperature. So the idea is you melt the solder without burning up all the other stuff. So you kind of want it to work at the lowest temperature you can. If you think you're trying to solder something that's big or whatever, these pins are kind of beefy. They're long, and they're not like a little thin wire. So instead of adding more temperature, you add more surface area. So you make your contact area between your soldering iron and whatever it is you're soldering, you make that bigger. So, that's why the little blunt tip on here is good for this versus the pinpoint tips are not as good for this kind of thing. So don't think of it, I guess y'all haven't had heat transfer yet, but think of it as, instead of just dumping more heat into the thing by increasing the temperature difference, think of it as making more contact area to transfer the heat better. And get your temperature more or less the melting point of the solder you're using, so that you're not overheating stuff, not burning up your tip and all that kind of stuff, and not risking, when you put heat into here, heat goes into the whole thing that it's connected to. So there will be heat transferred all the whole thing. Yeah.
So whenever we're making pins, you can't have them touching.
Oh, right. If they bridge across here, like if, and this is not going to show up very well, but if you get a bridge from pin 1 to pin 2, then those are connected together. And that's the thing that the solder mask should help, and the flux will help them stay where the mask is not. So if you use the flux and you don't have to even be super careful. In fact, if you've ever seen somebody solder a surface mount thing, like this set of thing, what they do is they take and put the object down, put flux on the whole thing, and run the solder all around there, and the solder mask combined with the flux keeps everything separated. So in this situation, probably the first time you soldered up this many pins through on a bridge, what are these things called? I don't remember what they're called. But anyway, the SD card reader. Then I would use, even if I had to use the old paste flux and figure out some way to get it from here to there, then I would still use it, because it will help prevent some of that bridging that you're going to have. If it does bridge, then you got to do something to separate them. Add more heat and try to pull the solder off. That's kind of possible. I don't know if we have solder wick, which is like braided copper wire that you can actually remove solder with. I don't know if there's any of that in the room or not. It probably might mean a mechanical solution where you take something and slice them apart even. $1 hacksaw works just fine, apparently. You just got to be careful. Don't hacksaw up your other stuff. If something horrible goes wrong and this thing, you get it soldered and it doesn't work, we do have replacement ones, because some of what goes wrong isn't your fault. It was built wrong to begin with. So if you're having trouble after you get it soldered up, then let me know. And we really did buy like twice as many of these as we need, because they're that cheap compared to the other version of these SD cards. All right, I think what we'll do now is let you do whatever it is you need to work on. Three of you, I think there's 3 setups. 3 of you can go over there and solder up stuff. You can ask questions. You can go eat breakfast. Whatever makes the most sense. And I'll post that Python code that I wrote on Moodle and try to get these soldered up for next. Oh, wait, that is important. So next week is career fair, right, on Thursday? All right, so the other class meets right after you during career fair, so they're not going to have class, and so to keep us in sync, we're not going to have class on that same Thursday. So we will have the Tuesday, but not the Thursday.